Hi everyone, this is Wednesday's video for equivalent fractions. So to start off, I have this little snapshot here, and it says equivalent fractions. So this is one way that you can do it using a model. So by model, they mean either a shape or some sort of figure where you can either shade in or have certain parts available for you to work with. So it says draw a fraction, then equally split each piece to create an equivalent fraction. So what they did here was they took a circle and they had it in fourths, and they shaded one of those fourths. And then what they did was they actually cut each of those fourths in half to create eighths, because we know that when you cut them in half, it makes smaller pieces, which means there are more pieces. So they're going to be smaller fractions. Therefore, 2/8 is going to be shaded in. And we know that 2/8 is equivalent to 1/4 because we didn't shade in anything extra. It's still just this one piece. But since we cut the pieces in half, this piece became two pieces. Therefore, you see that 1/4, one of the total 1, 2, 3, 4 pieces, is equivalent to 2 of the total 8 pieces here. So basically what they did is they just cut these fourths right in half like that to show that 2/8 is equal to 1/4. You can also multiply to find an equivalent fraction as long as you're multiplying by the same number for the numerator and the denominator. So in this case, they multiplied by 2. So if you want to multiply by 2, that's fine, but you have to multiply the top by 2 and the bottom by 2. You can multiply the top by 10 and the bottom by 10, the top by 1,000,000 and the bottom by 1,000,000, and as long as you're multiplying both the top and the bottom, or the numerator and the denominator, by the same number, then it's going to be an equivalent fraction. So in this case, 1 times 2 is 2, and 4 times 2 is 8. Therefore, they are equivalent fractions. So you can see this one was fourths. I cut it right into eighths. You could also then cut it into 16ths. So you could cut each of those additional pieces in half again to get another equivalent fraction. But that's one way to do it using a model. So I'm going to do a few worksheets here to show a few other ways that we can see equivalent fractions. Hopefully you can see on the worksheet here. So the top says fractions are equivalent when they name the same part of the whole. Equivalent fractions are different names for the same amount. Follow the directions. Write equivalent or not equivalent on the line. So basically what they're saying here is that equivalent fractions are the same value and the same amount, but they have different names. And the reason why that's important is because, for example here, with 1/4 and 2/8, it's different fractions, but it's the same value. 1/4 is equal to 2/8. So if you were to say, would you prefer 1/8 of a cake or 1/4 of a cake or 2/8 of a cake, it's actually the same amount. So that's just really important to be able to follow along with fractions. So let's go up here. So it says color 2/6 of the apples red. So we're going to color 2/6 red. And then it says color 1/3 green. So we have 6 apples. So we know that with 1/3, we go with every group of 3. One of them is colored in. That's why it's 1 out of every 3. So we'll do 1 out of these 3, and then 1 out of the bottom 3. And then it says 2/6 is blank to 1/3. So if we look back, 2/6 of the apples here, there are 6 apples and 2 of them are colored in. Then over here we have 6 apples and 2 of them are also still colored in, even though we had them in thirds. So we know that 2/6 and 1/3 are equal. So rather than writing equivalent, I'll just write the equal sign. So 2/6 is equal to 1/3, okay? There is the first one. And you can see that they're written differently, and they might look like different values, but really they're actually the same. So the next one is color half of the flowers pink. So there's 4 on the top row, so I'll do 2, which is half, and then 4 on the bottom row, which is 2, which is half. So we have 4 of the total 8 colored in pink. Then over here it says color 2/4 yellow. So the top row has 4, so we want 2 of those 4 to be yellow. And then the bottom has 4, therefore we want 2 of those 4 to be yellow as well. So when we look, it says 2/4 and half are, and when I look, I see that we had 4 of the 8 shaded in here, and then 4 of the 8 shaded in here. Therefore, 2/4 and 1/2 are equal. All right. The next one says color 1/3 of the leaves. Then the next one says color 1/4 red. So it doesn't specify what color, so I'll just color 1/3 of the leaves purple. So there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you could either take 12 and break it up into 3 groups. Therefore, if it was broken up into 3 groups, it would be 4 leaves. Or the way you can do it is every 3 leaves, you can color in 1. So there's a few ways to do it. So for every 3 leaves, we have 1, 2, 3. We'll color in 1. Because basically we're coloring in what our numerator is out of our total denominator. So our total denominator is 3, so we're coloring in 1 of those 3, 1 of those 3, and 1 of those 3. And it's still 4. So there are 4 leaves total there. And then over here it says color 1/4 red. So we want to color in 1 for every 4th, or we could take the 12 and divide it by 4 groups, which would be 3 leaves that we're going to color in total. But just to show you, 1 out of every 4. So here's 4, 4, and 4. So we're going to color in 1 out of each of the 4, out of each of the 4, and 1 out of each of the 4. So if I look at both, I have 4 leaves colored in over here, which is equal to 1/3, and then I have 3 leaves colored in over here, which is equal to 1/4. So when it says 1/4 and 1/3, I know that they are not equal because 1/4 is less than 1/3. So I'm going to do equal sign, then cross it out. So not equal. Or I could have written not equivalent. And so something else to know is that when they have the same numerator, you can actually just compare the denominators. So 1/3 versus 1/4. We know that not yesterday, maybe on Monday, we talked about how when you invite more people to your birthday party, you get less cake. So the more people that they are and the higher the number, the smaller the pieces. So when you compare 1/3 and 1/4, you know that 4 is a larger number, so there's gonna be more people, so smaller pieces of cake. So the higher the number, the smaller the pieces, which means that it's a lesser value. So 1/3 versus 1/4, we know that 1/4 is gonna be a smaller amount than 1/3. And it's kind of hard to picture with leaves, but if you always want to check, you could draw 2 circles. So thirds are gonna look like this, with 1/3 colored in, whereas fourths are smaller pieces, and 1/4, you can tell that 1/4 is smaller than 1/3. But we recommend using any sort of strategy other than drawing to figure out if they're equivalent or non-equivalent by kind of what we're showing you here, rather than drawing, because sometimes if our drawings aren't perfect and they're really close, then it's hard to tell. Okay, so for the next one, it says color 1/3 of the caps blue. So I see rows with 3 in each. So for every 3, I'm going to color 1 cap blue. So 1 in this 3, 1 out of this 3, and 1 out of this 3. Then over here it says color 3/9 orange. So 3 out of every 9. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a total of 9. Therefore, we're just going to be coloring in 3 of those caps orange. So when I look back, I see that there are 3 over here and 3 over here that are colored in. So they are equal. We talked a little bit about multiplying. So when something's equal, you should be able to take both those fractions and figure out what you can multiply by. So 9 divided by 3 is 3. Therefore, 1/3 times 3 over 3 equals 3/9. So 1 times 3 is 3. 3 times 3 is 9. And this doesn't change the value when you multiply it because 3 over 3 is 1. So when I was talking earlier with this model, when you multiply something by the same numerator and the same denominator, it doesn't change the value because we know that when something is the same on top as it is on bottom, whether it's 1 over 1, 5 over 5, or 1 million over 1 million, it's still just 1. Because if you have 1 million of the 1 million pieces of the cake, it's still just one whole cake. Therefore, when you multiply anything by 1, that's the identity property, which is the number stays the same, or the value stays the same. So the value of these two fractions is still the same. You're just multiplying it by 1, and for 1 we used 3 over 3. Therefore, it's going to change the way the number looks, but it's still the same value. So that sounds a little confusing when I say it like that. That's why we kind of like to show you all the different ways of coloring it so that you have different options to work with rather than always multiplying and dividing, which is what you will do in 4th grade, so it is great practice. But like I said, we like to show you a couple different strategies. So here's another one. So it says, equivalent is another word for equal to or the same. Fractions that are equivalent are equal. They are different names for the same size parts of a whole or a group. Fractions that do not name the same size part are not equivalent. Shade the first shape to show the fraction. Then shade the second shape so that it is equivalent. Finish the math sentence by writing the fraction for the second shape. So this is focusing totally on equivalent fractions. So we'll shade in first our shapes. So for number 1, it wants us to shade in half. So 1 of the total 2 pieces would be just one side. So then it wants us to do the same exact equivalent fraction over here. So we'd shade in the same thing, which is half. But this fraction would look a little different because whereas this fraction had 2 total pieces and 1 was shaded in, this one has 4 total pieces and 2 are shaded in. So our fraction would be 2/4. So 1/2 is equal to 2/4. And if you wanted to multiply it out to test it, you could do 1/2, 2/4. So are they equivalent? So how do you get to 2 from 4? So 4 divided by 2 is 2. Therefore, if you multiply it, because we know that multiplication and division are opposites, you should be able to multiply it to do the opposite. Therefore, 1 times 2 is 2, and 2 times 2 is 4. And that does make sense. And remember, 2 over 2 is equivalent to 1. Put that in parentheses, just so we remember. Because it's not changing the value, it's going to make it look a little different. All right? So now we have 1/3. We'll shade in 1/3. Then over here, we'll shade in the same exact value. But again, it looks a little different because each of these shapes, or each of these pieces were cut in half. Therefore, instead of 3 pieces, there are 1, 2, 3, 4, 5, 6, and 2 of them are shaded in. So therefore, 1/3 is equal to 2/6. Okay? So then we'll do a few more of these. 2/3. So 2 of the total 3 pieces are shaded in. So we'll do the same thing to this figure. And again, each of those pieces are just cut in half. So we're going to have double the amount. So whereas this one had 1, 2 of the total 1, 2, 3 shaded in to make it 2/3, this one has 1, 2, 3, 4 of the total 1, 2, 3, 4, 5, 6 shaded in. Therefore, 2/3 is equal to 4/6. And since we are doubling it because each of these pieces are cut in half, you should be able to multiply it to check your work. So 2/3 times 2 over 2 equals 4/6, which is exactly what we have. So that makes sense. For our next one, we have 1/4. We're going to color in that same amount over here. So again, these pieces are just doubled, so they're multiplied. Therefore, here we have only 1/4, and here we have 1, 2, out of 1, 2, 3, 4, 5, 6, 7, 8 total pieces. So 1/4 is equal to 2/8. So you can do the same thing through this whole worksheet. This was just my example for the video. That's how you find equivalent fractions. So your work for today will look like this. Fraction bars. So you just have to name the fraction for the first fraction bar. So you would name what this fraction is above. Then you color the second fraction bar to represent an equivalent fraction, and then you write what that equivalent fraction is. So I'll just do the first one for you. We do have an answer key up, but I just want to walk you through one of them. So this first one would be, there's 1, 2 of the total 3 pieces filled in, so that would be 2/3 equals, so they want us to color the second fraction bar to represent an equivalent fraction. So we color it right up to the same amount. In this one, we have 1, 2, 3, 4 of the total 1, 2, 3, 4, 5, 6. So 2/3 equals 4/6. And again, you can always check this with math. This is kind of an extended step, but you will eventually need to know how to do it. So I like to just show it just in case. But basically you take this fraction or this fraction. So we have 2/3. How can we get this denominator to equal this denominator? So thirds, to get 3 to 6, you need to multiply it by 2. Or to get 6 to 3, you need to divide it by 2. And then to get this fraction to equal this fraction, you would need to multiply. 2/2 is equal to 1. So we're not changing our value, we're just writing it differently. So 2 times 2 is 4, 3 times 2 is 6. So therefore that does make sense. Again, I'll stress this one more time. This is an extended step. This is really all you need to be able to do. I just like to explain kind of that in between what we're actually doing by changing this shaded area of this hole to this shaded area of this hole and how that looks mathematically. But really all you need to be able to do is the shading and writing down what that fraction is and actually identifying it. So you'll have to do that with all of these, and conveniently each fraction bar starts at the same point, ends at the same point, and it's all even pieces. Therefore you're able to just color right up to where the above piece is colored to, and then just count the number of pieces of your total amount of pieces to be able to find the answer to the problem over here. And so this should be pretty simple for all of you. One other thing I wanted to show you, this was equivalent fractions but with fraction bars or fraction strips. So I'll do 1 or 2 examples here. So it says, color the fraction strips to show the equation. Then write the missing numerator. So this one wants to compare halves with eighths. So it wants us to color 1/2. So I'll highlight that. So 1/2 there, and then it wants us to color in 1/2 here. And then it wants us to compare it to eighths. So let's color that in with green. So we'll do the eighths in green. So we're gonna color right up to where the pink colored up to. 1, 2, 3, 4. We colored in 4 of the total eighths. Therefore 1/2 is equal to 4/8. And with the last worksheet and with this worksheet, the fraction bars line right up with each other, so you can compare them. But like I said, when you draw things out, it's not always perfect, so you can't always compare when you're kind of drawing things on your own. So just be careful with that. If it's usually on a worksheet or a test where everything is lined up, you'll be fine. But sometimes you won't always have that. All right? So over here, they want us to compare 1/2 and 6ths. So we shade in the first half, pink, and then they want us to compare it with 6ths. So we shade all the way up to where the pink is shaded. 1, 2, 3. So 3 of the total 6ths. And for both these top examples, 1/2, you can also identify an equivalent fraction by looking to see if the denominator and the numerator, if the numerator is half of the denominator, so for example, we have 4 and 8, so 4 is half of 8, therefore it's equivalent to 1/2, because anything where we can multiply it or divide it in half, they're equivalent to 1/2. So again, over here, our denominator is 6, 3 is half of 6, which 3 is our numerator, so therefore we know it's equivalent to half. I'll do one more right here just so it's a little more clear. So we'll shade 1/2 pink. And then they want us to compare it with fourths. So we'll shade the fourths up until the end of the half. And so we have 1, 2 of the total 1, 2, 3, 4. So 2/4, and 2 is half of 4, so we know that that's equivalent to 1/2. So this other worksheet has a couple of other examples, but hopefully you guys have it down by now. If you need any further help with this, just let me know. But this one should be pretty easy just because all you really have to do is color and identify. All right, have a great day.